So I'm going to recap again what we have done so far. So last week we are learning about the DC motor control. This is a very basic motor that you need to learn and understand how to control first. And it is very important. You can open up your book. Your book start reference from page 73 up to 79. 73 up to 79, Alright, this is the reference for today. So you can start jot down everything very important to stuff. So I'm going to tell you what is all about controlling DC motor. So this one I'm going to skip because we have learned so far on this one. We go back for the pins that require to drive a motor. So the pin which is needed to control the motor is the CCP pins. You look at the front of your book. I purposely put that particular pin assignment for you to remember. Let's say that every day you look at this picture and you imagine that, and at the end you can remember all those pins. The pin which is very important is they call it capture, compare and PWM CCP pins located at pin port C, pin 1 and pin 2. On your book you can see there are two pins that is going to be used for the controlling of the motor. So what does it coming from this pin is the PWM, pulse width modulation. The PWM, the main purpose of having this particular pin is to control the speed of the motor. Speed, kelajuan. Okay, so you can control your motor up from the lowest speed up to the highest speed based on the parameter on the motor itself. So the PWM is the one that giving the voltage from 0 up to the maximum 5 voltage. It's from 0 to 5. You can control it. But in MicroC there's a library, they call it PWM library. You can use it from 0 up to 255. Remember that, right? MicroC give you 0 up to 255, and this is level reference at 0 volt and this level at 5 volt in your MicroC library. So this is used to control the speed. Alright, so that's why in your CCP pins over here, back to the picture again, there are two CCP pins over there. Which one? One is the port C pin 1 and another one is port C pin 2. So why does it require 2? And what is the advantage of that? Which means that you can actually drive two motors instead of one. You can drive two motors with different speed. This is very important if you have a robot or whatever autonomous robot, mobile robot, where you want to control is moving from here to there or turning. Especially is related to turning position. Back and forth is different, that one is direction. But to turn, you will require to play around with this pulse width modulation. So just imagine, you have a motor like this. You want to turn your motor over there, you have two wheels that is running together. So for example, its velocity is the same. So how you can turn over here? You can stop this one, right? And then you still moving up this one that is going to move over there. Same like the other side. So you have to stop here and then you have to turn like that. That is like 90 degrees turning. But sometimes you may not need to have 90 degrees turning, right? So maybe you just want to tilt a bit only. So it means that you still can have this one functioning, but lower speed than here. is still turning but different angle. Right? So if you want to turn over here, this is slower, this is higher, faster. So it's going to turn over here with a different angle. It's not like 90 degree. So that's why this PIC can control two motor at the same time. CCP1 and CCP2. Okay? Right? So again, this one, the terms. So back to the picture again, CCP1 and CCP2, this is the name of the pins. So if you want to give signal out, you must declare this pin as output. So that's why you have the try-C statement. This one will be 00. It must be output. Else you cannot generate the PWM signal. If you declare it as input, so I don't think so it's actually, what you call that? Okay, no? Because you are not getting input, right? You are putting out, you are generating the output go to the motor. Alright, so this one. Then you have the term for PWM. Remember that the PWM is what period, pulse, everything. So this is actually how you can control the speed of the motor. Basically, how is based on this area under the graph is the percentage of the voltage. So for example, if you have a full PWM, you are putting the highest maximum voltage, which is 5 volt, you are driving it the highest speed. This example is only 25% from the whole period, means that from 100 RPM, so your motor can be drive only 25% of the maximum speed, so around 25%. That's why you can see last week, when we played around with the LED, you can see that lower, smaller PWM will give a very not bright. Your LED is very dim. Compared to the higher level of PWM, you can see that your LED is brighter. This is a reference with the reference of the voltage also, means that the higher the voltage, the brighter your LED will be. So it means that you're controlling over that. Okay? Now, next one. After the speed, what you need to do is you need to know the H-bridge function. The H-bridge function is to control your direction, the directions of the motor. No more speed. That's the difference on that. PWM is to control the speed, and the H-bridge is to control your directions of the motor, whether it's going to be clockwise or counterclockwise. So this is the H-bridge inside the chip. On your board, the bridge is called L293D. You have to look at the board because we are going to do the programming based on the board. L293D is located at DC motor driver and encoder. You should know that where's the component. Where's the component? L293D is the H-bridge. Look at it. L293D is on the board, is at the sections of DC motor driver and encoder. So what does it mean? That when you want to play around with motor, you must have this driver. This driver is a H-bridge driver, which is going to receive the signal from the CCP pins and also the signal from your PIC to control its direction. So you must have this driver, else you cannot control it. Without this one, you cannot trigger the speed. You cannot control the speed of your motor driver. You can only give directions, but you cannot control the speed because the speed is coming from CCP pins. You cannot just simply put CCP pins talk to the driver because your motor have only two inputs. that to input must be coming from driver, which is going to describe its direction. So let's look at your L29 3D. This is the component and pin assignment. Look carefully, So I will give you two images. Another one is this one. Okay, this one, this image is coming from this book. This book is the board manuals. So when you purchase this one, they give you this book. What is inside here? The book is telling you the design of the board. The board is hardwired, means hard-coded everything, means I cannot change anymore the design. Means that, for example, port D all connected to the LED from pin 0 to pin 7 is all already on the board. I cannot change it anymore. So that's why after you know how it works, how the design looks like, you should be able to program it accordingly to the design. Now example here for your motor driver. Look at it correctly over here. This is L29 3D. Your driver, this is already on the board, design dekat atas tu. I cannot change it. So you have to play your coding based on this one. You are going to write the software and you have to play with this one. So look at how you want to read the technical over here. This one, when you work in industry, they give you this particular drawings. You need to understand how you can read, especially on design team. So when you read this one, this is L29 3D versus the physical just now. This is physical. Just now is different, right? Just now is like a Proteus. This is a physical. You know that you have around 16 pins on the chip. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 16. Each of the pin will have its own assignment. So they will give you the pin, they will give you the chip, look at the pins correctly. So you have to understand the data sheet first. For L29 3D, you look here first. The first pin is functioning to receive the CCP pin signal, which is to receive the PWM signal, this one. Enable 1, 2 means that the PWM will control the speed for one motor with 2 inputs, which is input 1 and input 2. Means that your motor must be connected to output 2 here. This is your motor. And you're going to use this pin to connect to CCP pins. And this one will give you the PWM, and the motor will rotate accordingly to the PWM over here. This is your PWM from this output motor. What does it mean for input 1 and input 2? Input 1 and input 2 must be coming from your PIC. So this is at whatever port that you want to use. So must be pin 1 input, input 1, input 2. The purpose of this connection is to control the directions of your motor. So back to the H bridge just now. The H bridge say what? You have to control accordingly to this particular table. Either to stop or to one direction, counterclockwise, or you can stall the motor. stop means jamming it. So here is the one that you need to generate the signal either 1 or 0, or 0 or 1, or 0, 0 to nothing, no speed. This is one direction and this another direction. If you put 1, 1, it will jam the motor. So now you have back to the L293D. This one, alright. So back to this drawings. Back to this drawing, you can see that from L293D, the input 1 and input 2, there is no more like physical just now. Input 1 and input 2 must be coming from port B, pin 4 and pin 5. Must be, because it's already on the board. I cannot change the trace. Means that you want to write your program, you must know that you are going to trigger the pulse or the value of the voltage coming from port B, pin 4 and pin 5. Okay? Then next one. RB6, RB7 is connected to in3 and in4. That is for another motor, but your board only have one motor. So we cannot simulate two boards. So we cannot simulate two motors on your board. You only can simulate only one, not simulate, you can put down there, but you can use Proteus to simulate your program. Alright? Now let's look at this point. This point they call it PWM. PWM is coming from your PIC pin CCP1 or CCP2, correct? Huh? So now let's look at over here. PWM is going to be over here for enable 1 and enable 2 pins. From L293D just now, enable must be connected to PWM pins, which is CCP pins. Must be connected. Alright? Next one. What else I need to tell you guys? So for you to run a motor, so you have to go back to jumper 20. Jumper 20 is on the board. Jumper 20 is on the board. So you have to set up 1 and 2 to jump for motor, 1 and 2 for motor over here. If you jump 3 and 4, they will go for DC. Sorry, they will go for stepper motor over there. So on the board, they have stepper, they have DC motor. It's sharing together. So choose DC motor to play around. Right? Now what else I need to tell you guys? VSS. Okay, for this example, for this motor, what you can see that VSS and VS having the same value for VCC. This is considered 5 volts, right? So means that your motor is operated at 5 volts. Anyway, it can operate with different volts like 12 volt and 24. But on the board now, seems like it is sharing the same node. So your power up VSS is to power up your L293D 5 volts, and also it's also shared with VS, means that the battery, the power for the motor is also 5 volts. Okay, try to understand. So the things right now is, there are two things that you need to understand carefully. PWM is to control the speed, and the H-bridge driver is going to be used to control the directions. But of course, you require this H-bridge to make it done, because you cannot simply run your motor without H-bridge, because you cannot put your CCP pins enable here to go to the motor, because your motor have only 2 outputs. That's why you will require a driver. So this driver can control your speed and your direction accordingly to your PIC programming. Okay, let's look at the simulator first. This is my simulation. You see it? Alright. You have to do this one also. Here is my PIC. Here is my L293D. Alright, VSS, I put it over here as 5 volt. And VS over here, I'm using external battery 12 volt, which means that my motor is using 12 volt battery to operate. Without that 12 volt, your board cannot functionally working because your board is only can give 5 volt. Your board is giving you only 5 volts. So the example here, my motor is operated by 12 volt, is connected to VS. Your enable pin is connected to CCP1. I'm putting here CCP1 because on the board is the same node. CCP1 and CCP2 is sharing together because it's on one board only. Going to enable 1, and there are 2 pins here, just now RB4 and RB5 is connected to port B, RB4 and RB5. This is to control the directions of the motor. So let's look at the simulation here. I have the oscillator here, and this is called oscilloscope, oscilloscope. So oscilloscope you can read of the data, so I want to run this one. Okay, look here. This is my motor. I drive it, I think quite maximum around 250 over 255, nearly 5 volt. So you can see that there's a point over here, the point over here coming down. I will try to look at another one. So you can look here now. If I have this pulse, right, you can see my movement of the motor. Then you also have to look at RB4 and RB5 triggering. Red means 5 volt, blue means 0 volt. So now red and blue, one direction over here. It stop. Stop. Nothing just now. 0 0. Oh no, this is a. Sorry, this is not mine. Sorry. My example now, you can see that this one RB4, RB5. RB4 is 1 and RB5 is 0. The direction is over here just now. And then I change it RB5 to red and RB4 to blue. The direction is the other side. So you can see that my PWM right now, this is around half of the PWM. The PWM is coming from CCP pins over here. Okay, so this is the PWM. Let's say I change my PWM value to let's say nearly 100 amp, 255. This is 127. Let's change it to 255 and 255. So I compile this one and run again. This is a full wave of PWM. It does not even just want to show this is the period. This is the period. So you can see that basically it's full. So now you can see that my motor is running at the full speed. This is my PWM just now. Just now, before this is 50%. You can see that the PWM is like that. Let's try another one. Not 50%, around 35% is around 127 divided by 2. Like around 60. I change this one to 60. 60. nearly 20% or 25% of the whole period. This is the continuous PWM. It does not 1 or 0. It always that period. So you can see that my motor is slower than compared to just now. Because of this PWM is a smaller PWM. Okay, understand? Okay, look at the code first. Look at the code first. My code to run a motor is this one. The main over here is to forward 60 over 255, which is this is the PWM, and delay for 1 second. I stop it and I move another direction and then delay, stop it again. So if you go back to this function, motor 1 forward is what? Motor 1 forward, bracket, I declare it as integer, and this is a name for the integer value 1. If you call this function, you will pass this value to over here. You will pass the value, So now, port P.F4 is equivalent to 1 and port P.5 is equivalent to 0. This is the one that you trigger just now for the H bridge operation. 1 0 0 1. This is another one, 0 1. If you trigger 0 0, it's not moving, right? If you trigger 1 1, it's going to stall it. So this is how you want to run a DC motor for a single driver. The task is for you to complete today is to simulate 2 motors on Proteus by using 2 CCP pins. So I have put it already inside ULearn what you should need to do, what you should do, and you need to post it back the answers by today. Both the image and the code. The code you just need to put inside Notepad. And for the image, Proteus image, you can just simply go to this one and then type snipping tool. Then you go for new one. Then you can snip this one only and save it to your desktop and send it to me. Alright, this snipping tool is powerful tool, is for you to do snipping tool. No more print screen. Print screen is very big. I just want the image only. Alright? Okay, understand? So you have time from now, nearly 1 hour, to complete the programming of 2 motor accordingly to what I want you guys to do from the ULearn. You can get my you can get my first program over here. This is my first program. Okay, that is my first program. Last week, why we cannot compile it? We found out the issues already because of the library. So we're going to solve today. I'm telling you why. So this is a code for driving a single motor. So from this one, you should know how to drive 2 motors simultaneously on the Proteus. I want you to use both CCP pins. Pin RC1 and RC2 must be used